Hello, my name is Budr Abdurazak Muhammad Basahi and my matric number is 191371. And now I'm going to talk about or summarize the metal semiconductor field effect transistor, Mesfet. The Mesfet consists of conducting channel positioned between a source and drain contact region. The carry flow from source to the drain controlled by Schottky metal gate. The control of the channel is obtained by varying the depletion layer width and underneath the metal contact, which models the thickness of the conducting channel and thereby the current. So as we can see the picture here, the key advantage of the Mesfet is the higher mobility of the carriers in the channel as compared to the MOSFET. The disadvantage of the MOSFET structure is the presence of the Schottky metal gate. It limits the forward base voltage on the gate to the turn-on voltage of the Schottky diode. This turn-on the voltage is typically 0.7 volt for gas Schottky diodes. The threshold voltage therefore must be lower than this turn-on voltage. As a result, it is more difficult to fabricate the circuits containing a large number of enhancement mode MOSFETs. So now let's see the basic structure of the MOSFET. So as we can see here in the picture, the basic structure, the gas MOSFETs are the most commonly used and important active device in microwave circuits. In fact, until the late of 1980s, almost all microwaves in integrated circuits use gas MOSFETs. Although more complicated device with better performance for some applications have been introduced, the MOSFET is still dominate active device for power amplifiers and switching circuits in microwave spectrum. The base material on which the transistor is fabricated is a gas substrate. A buffer layer is epitaxially grown over the gas substrate to isolate defect in the substrate from transistor. The channel or the conducting layer is a thin, lightly doped conducting layer of semiconducting material, epitaxially grown over the buffer layer, since the electron mobility is approximately 20 times greater than the Hall mobility for gas. The conducting channel is always N-type for microwave transistors. So now I will talk about the basic operation of MOSFETs. The basic operation of MOSFET is easily understood by the first considering the IV characteristics of the device without the gate contact. As shown in the figure, if a small voltage is applied between the source and the drain, a current will flow between the two contacts. As the voltage is increased, the current is increased linearly with an associated resistance that is the sum of the 2 ohms resistance Rs and Rd and the channel resistance Rds. In the basic operation of MOSFETs, if the voltage increases further, the applied electric field will become greater than the electrical field required for saturation of electron velocity under large base condition, and an alternative expression for ID is useful. This expression relates the current directly to the channel parameters, as we can see here the equation. To summarize the presentation, the operation is very similar to that of GFET. The p-in junction gate is placed by Scotty barrier, and the lower contact and p-in junction are eliminated because the lightly doped p-types substrate is replaced by semi-insulating substrate. Now I want to add one more thing, which is applications. The higher transistor frequency of the Mesfets make it particularly of interest for microwave circuits, while the advantage of Mesfets provide a superior microwave simplifier or circuits. The elimination by the diode turn on is easily tolerated. Typically, depletion mode devices are used since they provide a large current and larger transconductance, and the circuits contain only a few transistors, so that threshold control is not a limiting factor. The buried channel also yields as a better noise performance, as trapping and release of carriers into and form surface states and defects is eliminated. That's all from me, and thank you for listening and paying attention.